This is 7.2. We're talking about sum and difference formulas. Do what? Go ahead. Oh, you need another. All right, so you will be given the identities, the trig identities that we're working on the last 2 days. You'll be given the unit circle, and you'll be given the formulas that we're talking about today. You will not be given what I'm about to write down. So where it says right here, angles on the unit circle, this is only for angles that are on the unit circle, which is what we're talking about right now. You guys need to write this down. For an angle that is on the unit circle, there's going to be an ordered pair, right? There's going to be an x value and a y value. Everybody understand that? Here's your unit circle. If I said pi over 4, you'd find pi over 4 and tell me what the ordered pair was. If the angle is on the unit circle, then the sine value of the angle, we'll just say sine of theta, is whatever the y is in your ordered pair. The cosine of that angle is whatever the x is of the ordered pair. The tangent is the y over the x. We've already talked about these reciprocal functions. You guys have seen them algebraically. You have seen them with SOHCAHTOA. You've seen all of these ratios. Now, in this case, since the angles that we're talking about are on the unit circle, your r value is 1. That's why these ratios are a little different. So if I asked you what the sine was and you told me y, then the cosecant, the reciprocal, is going to be 1 over y. If you have a fraction and you're asked to find the reciprocal of it, what do you do to it? If you have the fraction 2 over 3, what is the reciprocal of that? 3 over 2. You just flip it. So if you have the sine value and they ask you for the cosecant, you just flip it and then you rationalize. So cosine would be secant, and it would be 1 over x. And then your cotangent would be x over y. These are not new. These are not new. This is just dealing with things that are actually on the unit circle. So if I give you flat out basic questions like what is the sine of 4 pi over 3? Well, go to your unit circle and find 4 pi over 3. What is the ordered pair at 4 pi over 3? What's the ordered pair? What do you guys see? Negative 1/2. So negative 1 over 2, comma what? Negative square root of 3 over 2. All right, so this question is asking you for the sine. What is the sine of 4 pi over 3? It's which part of the ordered pair? Y. It's the y. So the sine of this angle would be the square root of 3 over 2. It's the y value. Negative. I'm sorry, there's a negative in front of it. Anything that's on the unit circle, you can find the angle and then tell me the sine, the cosine, that sort of thing. So if I ask you what the cosine is of 5 pi over 6, go to your unit circle and find 5 pi over 6. What's the ordered pair at 5 pi over 6? Negative square root of 3 over 2, comma what? 1/2, okay? Now think about it. What is the cosine of an angle? Which letter? It's the x value. So in this case, guys, what is the cosine here? Negative square root of 3 over 2. It's the same thing. A lot of times, I mean, there's only 3 different options on the unit circle. 1/2, root 2 over 2, square root of 3 over 2. The signs are different given whichever quadrant it's in, but there's not, you're going to see a lot of repetition here. But in order to find these guys, you'll have the unit circle. You just find it. Find the ordered pair on the unit circle and then decipher. Do you need the x value? Do you need the y value? If I look for tangent of pi over 3, so what is the ordered pair? You guys tell me, I'm not looking. What is the ordered pair at pi over 3? 1/2, comma, square root of 3 over 2. Now remind me again, guys, what is tangent? It's y over x. So you take the y value, square root of 3 over 2, and you divide it by the x, 1/2. If I have a fraction divided by a fraction, what does that give me? Good. Square root of 3 over 2 times 2 over 1. So what happens? The 2's cancel and you're left with the square root of 3. That's it. Good. The tangent and cotangent are the only ones you got to do a little bit of work on. All right. We'll come back to tangent and cotangent at the bottom here. All right, guys. So when I talk about, if I say cotangent, All right, I want cotangent of 7 pi over 4. Well, let's first locate 7 pi over 4 on our unit circle. What is the ordered pair at 7 pi over 4? Tell me.
The reason they did it.
All right, cotangent. What's the ordered pair again at 7 pi over 4? Square root 2 over 2. Negative square root of 2 over 2. Okay, now guys, think about what our ratios are. What is cotangent? It's x over y. So take the x value, square root of 2 over 2, divided by the y value, negative square root of 2 over 2. What do you notice about this, guys? It's the same thing divided by itself, right? So what does it equal? 1. If one of them's positive, one of them's negative, what is this going to be? Negative 1. Good. All right, so cosecant 5 pi over 3. We'll find 5 pi over 3. What's the ordered pair at 5 pi over 3?
1/2
Negative square root of 3 over 2. All right, now let's think about cosecant. What does cosecant go with? Sine. So it's 1 over y, right? It's a reciprocal. So if I take 1, put it over my y value, square root of 3 over negative square root of 3 over 2. How do we do this? We keep change flip. So 1 times negative 2 over root 3. So I get negative 2 over square root of 3. Can I leave it like that? No. I'm going to rationalize. So this becomes negative 2 root 3 over 3. Could you have just flipped it from the beginning and then rationalized? Absolutely. I just want you guys to see that. All right. Secant of pi over 6. What is the ordered pair at pi over 6? Square root of 3 over 2. Comma 1/2. All right, secant. What does secant go with? What value? It's 1 over x. What do you guys notice about this one? It's the same as the one we just did, isn't it? Just a different sign. So this is going to be 2 square root of 3 over 3. All right, so here we go. Now, let's talk about these last two. These are quadrant angles. These are ones that aren't in any quadrant. They're on like the 30, 90, 180, 270. So think about 3 pi over 2. What is the ordered pair, guys, at 3 pi over 2? Look at your unit circle. What is it? 0, negative 1. So this is my x value. This is my y. How do you find the tangent? What over what? It's y over x. Take the y value, negative 1, over the x value. What is the answer to this? None. Undefined. There you go. Like that. No. No. Undefined. Good. So let's look at pi. What's the ordered pair at pi? Negative 1, 0, right? So what is cotangent? X over y. So take the x value, negative 1 over 0. What is the cotangent? Undefined. No. If you have a number in the numerator and a 0 in the denominator, your answer is undefined. What if it's the other way around? Then it's 0. Good. Okay, so we're going to take this information in our unit circle, and we're going to go on to this next piece. After I'm done with this, I want to do 2 examples of this, and then I will go over the yesterday's stuff. The formulas for addition and subtraction formulas for sine, cosine, and tangent. Now, if you notice, there's 3 different trig functions we're talking about: sine, cosine, and tangent. But what do you notice about underneath those? There's how many? There's 2, right? I have 2 for sine, I have 2 for cosine, and I have 2 for tangent. So what we're going to do now is you're going to be given an angle that's not on the unit circle. And you're going to use combinations of angles that are on the unit circle and these formulas to answer those questions. So do you notice how this has an S and a T in it? Some formula sheets have a U and a V. Some have an A and a B. All it's saying is 2 different angles. You could put a heart and a smiley face if you want to. But there's 2 different angles. So if you go, take a picture of this. Put it on the next slide. I don't think I put it on there. And I want to change this one to, I think I changed it last period, to 13 pi over 12. All right, the question is going to say, find the exact value. That means no decimals. That means don't throw it in your calculator and tell me what it is. I want to know the exact value. That means you're probably going to have a square root. But what is the exact value of the given angle? Well, the first thing you hope is that it's something that's on the unit circle, and then you could just pick it out. You could just pick, oh, sine, y value, here you go. So if I am going to change this to degrees so I know where it is, right? What's 13 times 180? 13 times 180. What is it? 13 times 180 divided by 12. I got 195. So I'm looking for the sine. Sure. All right, so here we go. This is how we're going to do this. First of all, everybody go to your unit circle. Do you see 100? Stop. Do you see 195 degrees? So when you're asked to find the exact value, you can put that in your calculator and get whatever the decimal equivalent is, but that's not what they're asking for. They want to know what the exact value is of the sine of 195. So you're going to use the sum and difference formulas, the addition subtraction formulas. You're going to find two angles on the unit circle, and there's a whole different variety of answers. But you want to find two angles on the unit circle that either add or subtract to 195. So give me some options. What could I use? Add and subtract to 195. What are two combinations that you could add the two together and get 195, or you could subtract and get 195? There's a bunch of different answers. Kevin, tell me.
150 and 45.
Perfect. 150 plus 45. You guys agree that equals 195?
Yeah.
All right, so this is how we're going to do this problem. I'm going to say, all right, we're going to use Kevin's example of 150 degrees plus 45 degrees. Okay? Name your first angle S, your second angle T. The hardest math you're going to have to do right there is either adding two numbers together or subtracting. This is it. This is the hardest you're going to have to do. Now, the next step is I want you to tell me what the ordered pair is at 150 and the ordered pair at 45. What's your x and y value at 150 and at 45? What is it? What's the ordered pair? Negative square root of 3 over 2. And what else?
45 is square root of 2.
No. What's 150? It's negative square root of 3 over 2 and what?
1 over 2.
At 1/2 positive. So at negative square root of 3 over 2 and 1/2. And then 45 is root 2 over 2 and root 2 over 2, right? Okay, perfect. All right, then another thing I want you to do to help yourself out a little bit, draw a little arrow and say, okay, this is my cosine and this is my sine, right? Your x is your cosine, your y is your sine. X is your cosine, y is your sine. All right, we haven't had to do much thinking here. Just figured out two angles that added to give me 195. So now we're going to figure out what formula we're going to use. What is the trig function that they want me to use? Sine. Okay, I want to find the sine of 195. So what I'm doing with that is I'm taking the sine of these two angles, 150 plus 45. You guys agree with me? Now, look at the formula. You should have the formula next to you. Okay, so you have your angles here in front of you. Which sine formula are you going to use? The first one or the second one?
Second.
What are you doing to the two angles?
1.
Are you adding them together or are you subtracting?
Adding.
You're adding. So this is the formula that you're going to use. You're going to use this formula right here. So follow the formula, guys, exactly how it says. All right, you're going to follow the formula exactly like it says. The formula says sine of S. Well, what is the sine of S? 1/2 times, what's the formula say? The cosine of T. What's the cosine of T?
1
Square root of 2 over 2. Good. Plus, what's the formula say? Cosine S. Right? What's the cosine of S? Negative square root of 3 over 2 times the sine of T. What's the sine of T? Square root of 2 over 2. Perfect. Now, all you're going to do, because exact value means, I don't want any decimals. I don't want any approximations. Just leave it as a square root. So, guys, I'm going to simplify above it, right? Because I have the formula. Well, now I can cross this out. Hang on. All right, so if you're going to multiply fractions, how How do you multiply fractions? Numerator times numerator, denominator times denominator. Okay, what's 1 times the square root of 2? The square root of 2. And what is 2 times 2? 4. Plus, what's negative square root of 3 times the square root of 2? Negative square root of 6 over, what's 2 times 2? 4. Now, guys, at this point, are the square root of 2 and the negative square root of 6 like terms? No, you cannot combine those. But what do you notice about the denominators? They're the same. So you would rewrite this as the square root of 2. You could say plus a negative or minus the square root of 6 over 4. That is it. That's it. When they say exact value, you're going to have square roots in your answer, and there's nothing wrong with that. But you cannot combine. You cannot cross out between the 2 and the 4 because the square root of 2 is not the whole number 2 where you can just cancel. It's some crazy decimal.
You can't subtract the top.
Nope, because they're not this. It's like saying x minus y. If it was like 7 square root of 2 minus 4 square root of 2, you could do 7 minus 4, and it would be 3 square root of 2. But since the radicals are different, you can't. So let's look at the next one. Cosine of pi over 12. Well, first of all, let's figure out what pi over 12 is. So pi, those will cancel. What's 180 divided by 12? 15 degrees. So we're looking for angles on the unit circle that'll add or subtract to 15. There's a bunch of different combinations, guys. What's one of them? Add or subtract to give you 15. 45 and 30. What else? 60 and 45. What else? 150, 135, right? Yeah, it does not. Everybody in here could do a different combination. As long as it equals 15, you'll get the same answer. I'm going to do the easiest. I'm just going to say 45 and 30. Now, since we are subtracting, which angle needs to come first? The bigger one, right? So it's 45 minus 30. Everybody with me? Okay, so let's do like we just did. What is the ordered pair at 45? Square root of 2 over 2. Square root of 2 over 2, right? What's the ordered pair at 30? Square root of 3 over 2 and 1/2. Okay, perfect. Now, what is the trig function that we're using? Cosine. We're doing cosine of 45 minus 30. Guys, cosine is tricky. Why is cosine tricky? Well, let's do this first. I'm sorry. Go ahead and label. Your x value is cosine. Your y value is sine. That's a good habit to get into. I mean, obviously I know it, but it's a good habit to get into. Look at the cosine formula. When you are subtracting angles, what's in the middle of the formula? A plus sign. All right, I'm giving you the formulas. So if you make that mistake, that's shame on you. If you are using the cosine formula, whatever you're doing at the beginning to the two angles, inside the formula, it's the opposite sign. So the cosine formula says cosine, cosine, plus sine, sine. So what is the cosine of your first angle? Square root of 2 over 2. What is the cosine of your second angle? Square root of 3 over 2. Yeah.
Does it matter which number is SUT?
I would, yeah, when you're subtracting it does. Because 30 minus 45 is negative 15, which would be in the opposite direction.
So the bigger number.
When you're subtracting, the bigger number needs to go first. So what's the sine? Root 2 over 2. And then what's the other sign? 1/2. A lot of times, guys, your answers are going to be very similar to each other. If I'm going to simplify this, what's the square root of 2 times the square root of 3? Square root of 6 over 2 times 2 is 4, okay? Plus, what's the square root of 2 times 1? Square root of 2 over 2 times 2 is 4. Can you combine anything? No. Can you simplify this a little bit? Yes, you can say the square root of 2 plus the square root of 6, or vice versa, over 4. Many times you'll get answers that are very similar because there's only certain patterns, there's only certain things on the unit circle. Does that make sense? All right, so when you are asked to find the exact value of the expression, they want you to use the sum and difference formulas. You just have to find the two angles that add up or subtract to give you the answer you're looking for, and then you just plug the sine and the cosine, the x and the y, into the given formula. Tomorrow, we're going to go over the same kind of thing, but it's working backwards. After I'm done with tomorrow's lesson, I just have practice problems that we're going to work through together, Thursday and Friday, to kind of wrap this up. Yeah. All right, so we went over 14 yesterday, so I'm not going to go over that one again. You guys should have that already. Let's go over the rest of them. We'll do this together. All right, we'll come back to 16 in a second. The way we should attack all of these problems is to say, okay, first thing I'm looking at, which side looks more difficult? The left, okay? Is there any trig function that is squared that's attached to a plus or minus 1? No. Do you have any addition or subtraction within your problem? No. So that means this one's easy. If you don't have any of those things, then just go right ahead and say, okay, what are our two most basic trig functions? Sine and cosine. So let's break it down. Cotangent is the same as cosine over what? Sine, okay. Tangent is the same as sine over cosine, right? And then I can just leave my sine x on the bottom here. What do you notice about the numerator? The sines cancel and the cosines cancel, leaving you with what number? 1. So this is 1 over the sine of x. What's another way I could rewrite 1 over the sine of x? Cosecant x, which is exactly what we were trying to get to. So in those two little steps, guys, you just proved that the left-hand side was equal to the right-hand side. This stuff in the middle here is your work that I'm looking for, not this final statement that says the left-hand side equals the right-hand side. Make sure you understand that. Questions? All right, let's go down.
Can you just leave it there?
Yep, sure, my bad. Yep. That's fine. All right, let's look at 51. Again, ask yourself, which side looks more difficult? The left. It's got more stuff going on. Okay, fine. Is there anything squared that it has a plus or minus? Nope. No. Are there any plus or minuses in the problem? No. So then just break it down right away to sines and cosines. What's another way I can write cosecant? 1 over sine. What's another way I can write tangent? Sine over cosine. What happens here, guys? The sines cancel. You're left with 1 over cosine, which is the same as, there you go. Now, in the last problem, Kevin just showed me he did his a little differently, got the same answer. Totally fine. Totally fine. There's not just one path to the right answer here. Sometimes we take longer paths, but that's okay. All right, let's look at this one, the unnumbered problem, because I forgot to put the number. Which side looks more difficult? Agreed, the left-hand side. Now, there's a couple ways you guys could attack this problem. I say, okay, I see something squared, and it's attached to a plus or minus sign. So when I think of sine squared, what's the Pythagorean identity that has sine squared with it? Cosine squared, right? If I change sine squared to cosine, is that going to help me at all over here? No. There's nothing that's going to help me break that up. So now I look at it, and I'm like, okay, let me think algebraically. I have two terms here. I have this term, and I have this term. Do you guys see anything that they have in common? They both have a sign, right? Can you factor that out? Yeah. Sure. So I'm going to take out one sign. Then I'm left with cosecant minus sine. Right? Some of you are like, okay, we're trying to get to cosine squared. How did that help us at all? Well, I don't have anything squared that's attached to a plus or minus. I do have a minus sign in the middle here, but I don't really see anything else I can do. So let's just go ahead and break anything into sines and cosines. Sometimes that just makes life easier. What's another way I can write cosecant? 1 over sine. And then I have minus sine over what? 1? Okay. Inside my parentheses, guys, I see two things. I'm thinking algebraically. I see two things. What do we call those two things? But what do you call these things? They do look like reciprocals of each other, but what are they in math? You have a numerator and a denominator. It has a numerator and a denominator. They're fractions, right? So if I had 1/2 and 1/3 and I'm adding them or subtracting them, what would I get? A common what? Denominator. So think algebraically. If you have two fractions and you're adding or subtracting, get a common denominator. So my little sign out here is just hanging out, sine theta. What is a common denominator between sine and 1? Okay, so sine theta. My first fraction has the sign, so the 1 stays there. My second fraction needs the sign, so what you do to the bottom, you do where? To the top. What is sine times sine? sine squared. All right. The reason that was so helpful was two things. First of all, do you guys see anything now that can cancel? What? The sign on the outside in the numerator and sign here. Now, is there an identity that has a squared and a sine and a 1?
Yes.
What is it?
Sine.
Sine squared plus cosine squared equals 1. Andre, would you just tell me 1 minus sine squared equals? Perfect. If I subtracted the sine squared from both sides, this equals what? That. So here you have cosine squared theta on the left-hand side, and what does it end up equaling? Cosine theta on the right. All right, let's look at this one. Which side looks harder? The left. I agree the left does. How come the left does? Because it's 1 minus cosine. It has a minus sign. The right one, if I wanted to, I'm not going to right now, but if I wanted to, could I break this up into 1 over sine x plus cosine x over sine x? Yep. And then what's 1 over sine x the same as? Cosecant. What's cosine over sine the same as? Okay, you could have done that if you wanted to, and then try to see if that helps you out or work anything. But I would always stick with the left side looks harder, so that's what I'm going to go with. Now, the left side has a denominator. It does not have a squared trig function, though. It has a trig function and a plus or minus 1, but it's not squared. So when we started off with a denominator like that, what did we multiply the top and bottom by? Yep, the conjugate, 1 plus. We're going to create our own identity, 1 plus cosine x. So in the numerator, leave the sign on the outside and the 1 plus. There's nothing, you don't need to put that together. Don't worry about it. But if we FOIL, guys, what's 1 times 1? 1. What's 1 minus cosine? So minus cosine. What's 1 plus cosine? Plus cosine. What's negative cosine and positive cosine? Minus cosine squared. Good. So what happens with our cosines in the middle? Cancel. You guys are going to start to see things. 1 minus cosine squared. Wait, what's that the same as? Sine squared. Good. So you have sine x up here. 1 plus cosine x over sine squared. Use that first Pythagorean identity. 1 minus cosine is the same as sine squared. So now what do they have in common? Cross off the sign here. Cross off 1 here. And what did you guys notice? It's the same. You should be able to solve these in 3 to 4 steps. If you are going more than that, you took a detour. Doesn't mean it's wrong. You just took a detour. All right, last one. If I did not help you with this, if I helped you with it, to me, the left-hand side looks harder than the right-hand side. To me. Some of you started on the right. That's fine. But to me, the left-hand side looks harder than the right. So I said to myself, all right, what can I do here? I see cosine and sine, they're both squared, so I might be able to use that first identity. But I look at the right side, and I was like, it's already in terms of cosine. So I'm going to leave this cosine alone. And I'm going to change sine into terms of cosine. What is sine squared the same as? No, okay, 1 over secant squared. But is that going to help us?
1 minus cosine.
Yes. It's the same as 1 minus cosine squared. It's that first identity that we have used now 19 times. Now, what do I do with this negative? I'm going to distribute it. So I have cosine squared x minus 1 plus cosine squared x. All right, if I have 1 plus 1, what does that equal? 2. If I have 1 bag of M&Ms and 1 bag of M&Ms, what does that equal? 2 bags of M&Ms. If I have 1 cosine squared and 1 cosine squared, what does that equal? 2 cosine squareds minus 1, which is exactly what we started with right there. Questions? All right, your homework that's due tomorrow morning should be done. You should be able to submit it right now because I did all of the problems with you. Now, 7.2 practice, you could do at least the first 4. You could do right now. You could do, well, not right now, we don't have a lot of time, but you could do tonight for practice. Do not do the tangents, just do sine and cosine. You don't have to do tangent. And then I'll finish the lesson tomorrow. We're just going to practice the rest of Thursday and Friday. We're going to practice this because you guys are going to get better at it, I promise.